Hello, my name is Ryan. I'm from Team 6364D, and this is my world's robot. So I'm recording this video just in case anyone wants to know what a robot does, because this robot, I'm about to give it away to my mentor. So I'm going to start off with the base. We have a 4-motor drive that's connected on standoffs and chain and sprockets, as you see right here. Bam, they're standoffs. This helps us in autonomous, so that we have lower slop, which is important. Sorry. Then another cool thing a lot of people liked about our robot was our anti-tips. So how these worked was that there's rubber bands tensioning down from here to here, and then when it gets released when the tray goes all the way forward. So I'll bring this back. So it stays right here, and then the trick is that there's actually these spacers that rub, those half-cut rubs on those spacers. It's a little smooth, and then when the rubber bands just tension it down, and then as you see, you can't bend it upwards. It's also screw jointed. I guess we'll move on to the tilter. So we have a 100 RPM, a 1 to 7 tilter. We try to angle our geometry, nothing special. It's connected like that, and that pushes out. Pushes out these rollers. What I shouldn't have done instead was make these rollers further out so they let go later, but this is the world's bot, and I really didn't care. That's about it. And this is our tray. So one special thing we did about our tray is that we did it on a screw joint, right? And then there's Lexan, and by the way, this is a key block. And we used a C-channel coupler to connect a 5-hole C-channel. Then we have these 135-degree brackets on screw joints. And it's another 35, and then a 35 slider. As you see, we use these screw joint and black spacers. That's special. Basically a 1961 slider. After that, this is our lift. So what we did here, we ran it on a 1 to 7, 100 RPM. We could have ran 200 RPM, but we really didn't wanted to for some reason, because I just wanted something more reliable, and then 100 RPM was the way to go, basically. We put our lift bars a little back, so we have a tension point from the back of our lift. Then we can tension it, rubber bands from here to there. And also we have another tensioning point from here to here. This really helps with, because the lift is so heavy, because of these boxed arms, we just wanted something super reliable. Yeah. Now more about our key block specifically. So it's actually incredibly simple. So we have a 15-hole C channel from the base, and then there's just a hinge. And then it's activated. There's usually rubber bands pulling on it, but I took every rubber band out for the next robot. And when this the lift lifts up, this lifts up, and lifts up just enough to hold the cubes like that. That's just enough. More about our cube block. Since our lift bar and tray, it was super close together. I couldn't really fit a lever in between, which is one of the design flaws on this robot. What I should have done was made this lift actually lower, so this tray could go down lower, and then, or wider, so I could fit a lever inside. or maybe I just don't know what I'm doing. So anyways, I just made this just for simplicity, as you see here. I haven't actually driven with this because coronavirus, and so, yeah. Now I want to talk to you about the lift, or I mean the intakes. So we have an 1812 chain using American rollers and double flaps. There was a really tank tread here, but we use that for something else that I won't tell you. And then this is a little janky because it's just one screw joint, and then when it folds in sometimes, the screw joint can bend out like that, as you can see, which is pretty bad. But it was reliable enough when it was flipped down. As you see, compression was a really big thing. And if I try to pull it back, it doesn't, because it's hitting this standoff, which acts as a single stop, like that. And also we have these simple half-cut locks. I didn't really rely on these. What I did rely on was the rubber band tensioning from here to, I think it was here. It would just pull it down. And sometimes our intakes, when we moved our lift all the way up, the weight distribution would bring up the intakes while scoring on the tower. So I just added this lock just for that reason. We also use small sprockets, so when our intake spreads out, it spreads out less, and so it doesn't hit the wall while scoring it, because if it hits the wall, it's like, it gives you less opportunities to have less space. When you use 1812, when it pushes all the way out, you're still going to have space when you make your stack, pretty much. What I just want to say is, you can build a really good robot if you can build it neatly and execute it good. You can be successful, and I hope you have great successes in change up. Bye.